So let's talk about nested dielectrics. I'll be trying to simplify it as much as possible, and if you are looking for a more technical understanding of nested dielectrics, you can check the web, but I'm trying to avoid any unnecessary confusion, just give you what you need in your scenes and then move on. So when rendering intersecting or overlapping transmissive objects, you need to be aware of how the objects meet. You know, things like liquids in glass. Before, when we had to deal with such situations, we had to make sure that these surfaces never really touch one another, because imagine if the liquid and water occupied the same point in space, the renderer would have problem rendering that point, so it could result in some artifacts in the final render. So we had to make sure the liquid is slightly smaller than the glass so they wouldn't touch each other, which is a bit cumbersome to set up, and in more complex fluid simulations it's almost impossible, and the final resulting render wouldn't be physically accurate. The solution is that the scene is modeled by making the dielectric or transmissive objects overlap, and in the areas of space where they overlap, the material is resolved into one of the overlapping dielectrics via a priority system. Now, dielectrics are modeled as closed surfaces which are allowed to overlap, but then we must specify which of the overlapping ones exists in a given region by assigning priorities. That is, we assign each dielectric medium an integer priority, and then in an overlapping area, the highest priority medium is the only one which is assumed to exist, and that is nested dielectric priority, which results in an easier setup and a more physically accurate render. Now, in this scene, you notice how the water is overlapping the glass and the ice cubes overlap the water. Let me run the IPR. I'm gonna hide the whole model. Let's unhide the ice cubes, then the juice, and finally the glass. So because the priorities for nested dielectrics are set up correctly, we get a nice physically accurate render. Let's take a snapshot for now. If I open up the glass material and come down to the transmission section, you notice its nested dielectric priority is set to 3, which is the highest priority in the scene. For the ice, it is set to 2, and for the juice it's set to 1. So the ice cubes have a higher priority compared to the juice. If I set the priority for all of the overlapping transmissive materials to 0, basically disabling nested dielectric priority system, you quickly notice it's less physically accurate compared to the previous render. If I take a snapshot and compare it to the previous render with nested dielectrics enabled, you can see the huge difference that it makes to the physical accuracy of the render. Now let's get back to our materials and talk about how to set up these dielectric priority numbers correctly. We have 3 overlapping dielectrics in this particular scene: the glass, the ice cubes, and the juice. I used 3 as the dielectric priority for the glass, which is the higher number, 2 for the ice cubes, and 1 for the juice. The higher the value, the higher the priority of the object. So for example, in reality, if you think about it, where there is glass, there is no juice or water, and we know that in this scene the juice overlaps the glass, so we need to find a way to tell Arnold that where there is glass, make sure no water or juice exists, and that simply can be achieved by setting the priority value of the glass higher than the one of the juice. When the juice, which has the dielectric priority of 1, overlaps the glass with the dielectric priority of 3, because the glass has the higher priority number, only the glass exists in that overlapping area and the juice will be ignored. And the same thing goes for the ice cubes and the juice. If you think about it, in our scene they overlap each other, but in real world they have their boundaries. There is no juice inside the ice cubes, and we simulate that by setting the priority of the ice cubes higher than the juice, and that is why the ice cube material has 2 as its dielectric priority and the juice is set to 1, and that is why we get this physically accurate render. So that's really about nested dielectrics. If you are into fluids, bubbles, liquids, and complex simulations, this feature is really amazing to have. Thanks for watching.